All right, let's get right into it. We've all seen AI do some pretty wild things, right? It can write poetry, whip up incredible art, even code software. But today, we're talking about something different. Something, well, maybe even a little bit harder. We're looking at a new tool called DeepSeek OCR, and it's totally changing how AI reads and understands our messy physical world. And yeah, that really is the big question, isn't it? Can an AI truly read? And look, I'm not talking about just scanning clean text off a website. I mean, we've had that for a while. I'm talking about the mountains and mountains of documents that, actually run our world. Just think about it for a second. We're talking about blurry scans of old newspapers, a doctor's handwritten prescription, those super dense financial reports with complicated tables, not to mention historical manuscripts in like 100 different languages. For decades, all this information has been basically locked away, making it incredibly difficult for computers to get in there and actually make sense of it. And that is the problem DeepSeek AI decided to tackle. So this really is AI's next big reading challenge. I mean, for years, we've had these traditional OCR tools trying to solve this. But let's be honest, they often fall flat with anything that isn't a perfect, clean document. They just leave behind this jumbled mess of unusable text. And that's where DeepSeek OCR comes in. But listen, this isn't just another small update. It's a completely different way of thinking about the problem. It represents a fundamental shift in how a machine can look at a page and genuinely understand it. Okay, so here's the key thing you need to get. DeepSeek OCR isn't just matching shapes to letters like a simple machine. No, it's a full-on AI model that's built to understand the content. It sees the layout, it gets the structure, and it converts all of that into clean, organized, editable text. It's the difference between blindly copying words off a page and actually reading it for comprehension. So the secret sauce behind all of this is this really cool technique called Context Optical Compression. Now, instead of that old school, slow pixel-by-pixel scan, this AI takes a step back and gets a high-level view of the entire page. Then, and this is the magic part, it compresses all that visual data. We're talking text, layout, tables, everything, into just a few hundred intelligent little packets called vision tokens. All right, so how does compressing a page into these tokens actually lead to readable text? Well, the easiest way to think about it is like a two-part system. You've got the eyes that see the page, and then you've got the brain that figures out what it all means. So first up, you have the eyes. That's the deep encoder. It scans the document and does that magic compression we talked about, turning a huge image file into just a couple hundred of those vision tokens. Then the brain takes over. This thing is a super powerful mixture of experts decoder, and you can just think of that as a whole team of specialized AIs working together. It takes those tokens and rebuilds the entire document's content, but as perfectly structured, clean text. And get this whole process is ridiculously fast. We're talking about a single high-end GPU processing over 200,000 pages a day. I mean, that is just an insane level of speed. It's perfect for any company or institution that's basically drowning in a sea of paper or PDFs. But, speed is only half the story here. This new method unlocks capabilities that older technologies could only dream about. We're going way, way beyond just recognizing letters on a page. I mean, look at these superpowers. The model was trained on a massive data set, 30 million real-world pages. It understands over 100 languages, everything from Chinese to Arabic. And, this is a big one, it actually recognizes complex things like charts and tables, and it preserves the document's original structure. Then it spits it all out into super useful formats like Markdown. And right here, you can see exactly what I'm talking about. On the left, that's what you usually get from a traditional OCR, just a chaotic, unstructured block of text. Pretty useless, right? But on the right, that's the DeepSeek OCR output. It's clean, it's structured, and you can use it right away. It's just night and day. And the performance numbers, they're just as impressive. Even when it's compressing the data by 10 times, it still holds on to an incredible 97% precision. And even when you push it to an extreme 20 times compression, it still manages to keep about 60% accuracy. That's pretty wild. Think about what that means. It's like trying to read an entire book by just peeking through a tiny keyhole and still managing to understand the main plot and who the characters are. It's just a huge testament to how efficiently this model can understand and then reconstruct visual information. Okay, so this is all very cool tech, but let's get to the big question. Why does this really matter? What's the real-world impact? Well, it all comes down to turning these dormant, forgotten archives into live, actionable data. This quote right here just captures the essence of its potential perfectly. This technology can literally unlock decades of human knowledge that is currently trapped in physical documents, making all of it searchable and analyzable for the very first time. And the potential applications are just enormous. We're talking about digitizing entire national archives, accelerating research for legal and academic fields, making historical records accessible to absolutely everyone. And maybe the best part, the model is open source. That means developers anywhere in the world can build on it, creating specialized versions for local languages and all sorts of specific needs. Now look, it's always important to keep a balanced perspective here. As groundbreaking as this all sounds, it's not a magic wand. This technology still has its limits, of course. So, like we saw, that accuracy does start to drop off at those super high compression rates. And yeah, really poor quality or distorted scans can still trip it up and cause errors. And to get that incredible 200,000 page a day speed, well, you're going to need some pretty serious hardware. So that brings us right back to our big question from the beginning. After seeing everything it can do, after understanding how it works, can this AI really read everything? The honest answer is not yet. But what DeepSeek OCR represents is a massive, massive leap forward. It's like a bridge connecting our messy analog past to a fully searchable, understandable digital future. So no, it might not read everything perfectly today, but it is without a doubt reading the future.